Proposition 11, Book 2, Euclid. Given a straight line, to cut the straight line so that the rectangle contained by the whole straight line and one of the segments is equal to the square on the other segment. So here we have our straight line. Now what we're going to do is, from this straight line we're going to construct a square. We know that we can do that already, so we will just construct the square. Construct it. Square. And the square, okay. So we have already a square. Now what we are going to do is we are going to bisect this straight line. We're going to bisect it. We bisect it. And now from this point we're going to connect to this point over here. So we connect them. From this point we connect to this point. Now from this point we're going to extend another straight line so that from this point on to the whole straight line be equal to this straight line that we have just constructed. So we're going to do that. We know that we can do that. We are going to just extend this one, extend it, and then we're going to cut this equal to this. So we do it. Now what we're going to do is from this straight line, from this point we can construct a line parallel to this straight line and equal to this. So we're going to do that. We do it. Okay. Now from this point we're going to construct a parallel straight line to this straight line. So we do it. We construct it. Now we made this equal to this. Okay. So what do we have here? Oh, do you remember prop number 6? It says that given a straight line that is cut in half and we add a part to it, the rectangle contained by the given straight line and the other part with the other part plus the square in half is equal to the square on the half plus the added part. So what do we have here? We have a straight line cut in half, and we added here another straight line. So it means that the given straight line plus the added part and the added part, that rectangle contained, plus the square on the middle segment is equal to the square on the half plus the added part. So the square on this. So what do we have here? So the rectangle contained by this and this is equal to the square plus the square on this is equal to the square on this. But we made this equal to this at the beginning. So what does it mean? It means that the rectangle contained by this and this plus the square on this is equal to the square on this. So what do we have now? We know that this is a right angle because we made this figure a rectangle. So this is a right angle, and we have that this is a right angle triangle. This is a right angle triangle. Therefore, knowing from Prop 147, we know that the square on this plus the square on this is equal to the square on this. So the square on this plus the square on this is equal to the square on this. But what do we have here? We have that the rectangle contained by this and this plus the square on this is equal to the square on this. And we also have now that the square on this plus the square on this is equal to the square on this. So two things equal to the same thing are equal to each other. So the rectangle contained by this and this plus the square on this is equal to the square on this plus the square on this. But we see that the square on this is common on both sides. So let's subtract this from both sides. So the remainings will be equal, because if we have two equal things and we subtract from the equals, the remainings will be equal. So the rectangle contained by this and this is equal to the square on this. Whoa, what do we have here? We have that the rectangle contained by this and this is this rectangle over here. And the square contained by this is this square over here. So we have that this big chunk, this rectangle over here, is equal to the square over here. So this rectangle is equal to this square. So, and we have this in common. We have this part from both sides. So we will just subtract this from both sides and the remainders will be equal. So this square will be equal to this rectangle. And what do we have here? We see that this square over here is the square on one of the segments, and this rectangle over here is the rectangle contained by the whole straight line, because this is equal to this, and a segment. So what do we have just done? We have cut our given straight line. We have just cut our given straight line on a point so that the rectangle contained by the whole straight line and a segment is equal to the square on the other segment. Thus we have shown that given a straight line, it's possible to cut on a point so that the rectangle contained by the whole straight line and a segment is equal to the square on the other segment. Quod erat faciendum.